Great. Next speaker is indeed now from a different country. We have, and that's great to have Goutam Samanta, who's the head of PV technology at Juniper Green Energy. Indian solar pioneer, has been in the industry for ages, and he has a lot to share. Nevertheless, Gautam, please stick to the time.
Hi, Michael. Am I audible?
Yep, all good. You're ready to go.
Okay. Thank you very much. And good morning, Michael, and also TaiyangNews research team. Today, I'll be presenting procurement and the system design strategies in a low-cost solar market in India. Okay, so there are the different parameters. First of all, the low tariff. So in India, as you know, the tariff was much lower, something like less than 2.5 cents, but now it has still better, like 2.8 cents or so, right? Okay. So for low tariff, what we need is an innovative approach, right? But there is no compromise on the quality and bigger plant size, which are agile executions approach. How the bigger plant size, I'll explain. So something like 250 megawatt kind of a plant size. Getting more from the less. This is very important in a sense, like and the engineering, the system designs, when you do actually higher AC to DC ratio, tested new designs and early commission. So requirement are something like, here is a cost. Cost definitely is a bigger number, like what we call the LCOE. Turnaround time, that means when we do the project, how quickly we do the commissionings, including all the BOS component. Reliable and the durable. Reliable means the component have a 25 years life. Not only that, if you look at the year-on-year basis, the low degradations, that is also very, very important and durable. And that means when we install the either module or inverters in the field, and as you know that India is a very, very high temperature, high humid condition, so it should also be durable without any kind of problem during the functioning, and 100% generations quickly. That means we always plan a kind of a pre-commissioning stage so that it comes at least 2 months early than the actual, the PPA signs in terms of the commissioning date, the COD date and all. And the solution is the value engineering. So we have to do a kind of I'll explain in details on that. And then tight project management, in a sense, like the whole project has to be, managed in such a way, the project management with all stakeholders. I'll explain in detail on that one, and quality at each stage of the EPC. That means right from the module procurement to the inverters and to the all structures, cables, transformers, and the combiner boxes, SD, components and all. The rigorous pre-commissioning, test. So this is also very important that I'll explain at later stage. This is the kind of a schematic of the solar power plant. And if you look at the left side is the DC side and the right hand side is the AC side. And there is an array on the PV panel on the modules, and in between the combiner boxes, then the inverter. Inverter plays a very important role, whatever the best, the modules, what you have. So it's decide, from the DC generation side and how much to be set to the AC side. Therefore, it's converting, not only converting from the DC to AC, but also there are several the components, say for example, AC panel, the switchgear, circuit breaker, and the step-up transformer. This also plays a big role in terms of the power generation and sending to the grid. And on the bottom also there are a different component which are is called the monitoring systems on the power plant. There are different sensors. There are different the kind of a weathering stations, like that gives a clear idea how the modules will be and not only modules, the power plant will be for next 15 years or so, right? So I'll discuss some things about the engineering capability and the concept. Like, first of all, to optimize the energy yield of the systems, considering the LCOE, which is the capex and the opex. Capex means the capital that we are spending for our project, and our opex means from the operating point of view for the expenditure, right? The selections of the modules and the inverter is very, very important on the DC side, because the module is the key component of the power generations, but now the technologies are park technology, which are dominating more than 60% of the present market. And most of the installations are monofacial or the bifacial, but I will give a recommendations in my next page, what are the things and how to go. Topcon is also available, and also in the HGT, which are called N-type modules. The inverter sides, there are two inverter configurations. One is that central inverters, and there's a string inverters, but definitely with the 1500-volt design systems. Then maximum utilizations of the string configuration, that also we have to see that how we have to utilize the string. Say, for example, there is a 1500-volt designs. If your module of 545 or 550-watt modules has got around 40-volt system, so you can easily combine like more than 28 modules in a series configurations. DC AC ratio, mounting structure is also equally important, because there are two different configurations. One is the fixed steel configurations, another is a single axis track. The mounting is such an important, I can tell you, in the different, not only the weather conditions, because sometimes there is a wind speed of more than 80 kilometers per hour, it goes to 90 and 100. So you have to see that the structures foundations are equally good and they pass the wind tunnel test. So landscape versus portrait, and the tilt angle. Tilt angle different kind of the locations of the power plant. Then land utilization factor. Land's topography is very, very important. And the power density factor for each land using the different row to row spacings at the side. This is very, very important in a sense, like morning to evening, 7 o'clock to the evening 6 or 7, depending on the locations, So we have to design in such a system the spacings of the row in such a way that shadowing doesn't happen, and we have a maximum generations. The cables and the connectors. So the DC and AC cable cross sections are very, very important. Their hardness and the Y connectors. The combiner boxes. These combiner boxes are with or without the monitoring systems. So both the configurations we have. No combiner boxes, the cable harness systems with the safety fuses and all, right? And number 6 is the inverter, the transformer configuration, that either 3 windings or the 5 windings. Number 7 is the switch gear configurations, indoor or it can be outdoor, 2 panel or 3 panel or the 4 panel. On the civil sides, this is very, very important that all foundations, the road should be done very nicely, and the trenches, particularly the DC and the AC trenches, there are communications cables and the earthing systems. Next is that, on the solar panel side, if you look that the module selections is very, very important. As I told you, there are more than 1,000 manufacturers globally. But when we do the selections of any module manufacturers, there are different rigorous processes. In a sense, we look into the technical aspect of the module configurations, and these modules are nowadays are bifacial module, glass modules. We look into the long-term performance, in a sense, like from the power delivery point of view to the warranty, both the things, and also from the generations perspective. So we look into the band file, we look into the temperature coefficient, which are very, very critical in India, because this is a high temperature operating conditions. So therefore, I will have my recommendation in the next page. AC/DC ratio, the PVC analysis is very, very important based on the temperature coefficient, and also other the BOM item of the modules. The simulations gives a kind of a and comfort level that what will be my generations from the power plant on a specific locations, but obviously it can be done either monofacial or in the bifacial configurations. The array layout planning is also very, very important. Detailed array, whether I can put 20 numbers of a module in my array, or it's more than that, but depending on the kind of module voltage, right? The structural is the mounting structure, and then the inverter container, the mounting structure, as I told you, all the structures has got a kind of a self weight, which is something like, for today, like 28 module configuration, something like 1.5 ton. So tonnage is also calculated, based on a per megawatt basis, in a sense, like it's maybe 20 or 22 tons and all. So inverter configurations, inverter means these are string inverters, or it's simple inverter. If it's a string inverters, then you have a different kind of a design configurations. So inverter kits that we have to look into for a simple configurations inverters. Then watchtower. Watchtowers means the security, we'll be looking into the, whole power plant, like that. So from the civil side, fencing boundary walls, it's very, very important from the first day, of the after acquiring the plant. The first of the job to be done is the fencing, so that you can protect not only the all equipment, but you have to make a store for that one, for keeping all of it in incoming device. I mean, foundations of the MMS, inverter pad, transformer, control room, these are all very, very essential part. And then the roads and the drains also from the civil side, because if there is a heavy rain zone, then you have to have a quite a good drainage systems, as well as roads, means of the movement of all the BOS components to the nearby the array, or the the locations. We have to be good road conditions, so that it has a less dust as well, so that it doesn't come and deposit on the surface of the modules. Then electrical side, SLD single light diagram, the equipment, inverter, the string configurations, and the transformers, whether it is HT panel, plant auxiliary supply, combiner boxes, and the cable. And then the lightning is a very, very important, arresters, and the earthing, and the monitoring systems, as I told you earlier. And then from the operations and the maintenance point of view, yes, in the module cleaning systems, whether it's robotic, mostly is it robotic cleaning systems, and the ventilation systems for the container. If it is a 40-feet container, then how it will ventilation system, particularly for a central. Well, for robustness of the systems in the module supplier selections process, there are several things like, 24 by 7 factory audit for the module supplier. And then what the normally developers do, that they deploy 24 by 7 the inspector during the productions. They monitor the productions, that they supervise the quality as per the QAP plan. And then there is a pre-shipment inspection or pre-dispatch inspections, depending on the how much production it is. Sometimes it is agreed that 10 megawatt or 15 megawatt as per the quality plan. And then there is a power selection. That means they check randomly as per the equivalent standards, how many samples to be checked, the power, and then EL, as well as, there are visual inspections, and finally the dimensions as well. And then from there, it is selected the less number of modules. It depends as per the quality plans, whether it is 30 or 10 numbers, going for further reliability tests, say for example the LID, LETID, or PID. But at the same time, it check the power verifications of the lab, and also the EL inspections, whether any kind of the microcaps are there or not. The testing of the sample modules on the successful on the third-party reliability lab is very, very important before issuing the MDCC. But warm verifications and the order placement, warm verification is very, very important, in a sense, like what kind of a solar cells, whether how many bus bars, how many fingers, and the cell design as well. And similarly, whether it is a kind of a the glass module, or maybe monofacial module, glass backseat, or maybe some other materials which are there, right? Value engineering is very, very important. The pitch analysis with the PV module and the inverter technologies, US component comparisons with respect to the different technology of the PV modules. That means different technology. I want to mean that whether it's the park modules, or the top down, or the HGT modules, and the inverter configurations, right? So inverter configurations is very, very important, in a sense, based on the the module, not only the power data, but also voltage and other things are very, very important. The BOS component estimated using the land's requirement, MMS quantity, cable length, PV module, inverter, and the transformer, LT, and the HT panel. Array analysis is very, very important. General perspectives is identifications of the true north. Then the cluster size approach for the optimum DC ohmic losses. Shadow analysis, the control room, whether this is a street light or the equipment or the nearby object. And then the inner table shadow is also constructions from the operations perspectives, coordinate array layout with the services such as cable, drain, and the road MCs, and access area planning for the equipment movement, evacuators, JCB, cable line, machines, container, transformer, etc., access area planning for the module cleaning and the vehicle movement. So this is a kind of the summary I have presenting here as a table on the module based on the different technology. First of all, PARC, TOPCon, and HGT. But my recommendations will be like, I'll have a, one more sheet, but temperature coefficient is very, very important place. As I told you, that the module on the PARC is minus 0.35% per degree Celsius per cell. But in TOPCon, it an advantage much lower, minus 0.29 to 30 per degree Celsius per cell. For HGT, minus 0.26 percentage per degree Celsius per cell. But obviously, efficiency in number 3 is also very, very important, because when we calculate in a cell level efficiency, but how it translates to the module level, normally 92 to 93% is the module efficiency. So module efficiency number 10 is very important, like 21.1% to 21.5% for the PARC. It means per square meter, it generates 211 to 215 wattage. Similarly, for TOPCon, it is increasing 221 to 225, and for HGT, 225 to 228.5. And then the other thing is the bifacility factor, because when we move from P-type to N-type, there is an enhancement in terms of the bifacility. In a sense, even in the fixed steel configurations earlier, because you can't have the 100%, the bifacility on the rear side, because only you can have a gain of 10 to 15%, albedo from the rear side. So the relative improvement, from 70% to 80% or 85%, you can imagine. So there is a relative 10% improvement on the rear side of the albedo. And then finally, the number 15, the power output at the end of 25 years, for PARC, it is 87.2%, for TOPCons, 89%, and for HGT is 90%. But one more factor is the year-on-year degradations. The first year degradations for the PARC is 2%, for TOPCon is 1%, and HGT is 1%. Though the actual degradation much less, but the module manufacturers are given a kind of they want to play safe. But if you look at it from second year to 25 year, for the PARC is 0.45%, but for TOPCon is 0.4, and for HGT is 0.375. But if you look from the second year to the 25, there is a cumulative improvement in terms of the efficiency. Efficiency means the degradation efficiency, I want to mean here for the TOPCon and the HGT. So these are most recommended for the Indian conditions where the high operating temperature, right? So my recommendation is that to go for a higher wattage modules, 540 watt, and the higher efficiency, as I explained you, higher wattage modules means that gives a low cost in terms of your structure, in terms of your cabling, and you can save the land as well. Bifacial module glass, these are the most recommended, and it's also witness. It's not only the low degradation, but in case of there is any kind of the micro crack developed during its transportations, or maybe because of the handling, then the cells doesn't get separated, or what I mean that the year-on-year degradations because of slightly micro crack, it doesn't make any kind of further defect in the modules or doesn't make any kind of damage in the module for further increasing in terms of its impact length and all, right? So lower year on year because I explained you earlier, the low temperature coefficient. And finally, fifth is the anti-reflection coating with the anti-swelling, because India is a kind of a country where you see anywhere there is a huge swelling losses. So therefore, what you do actually normally that every second or third day we run with the kind of a robotic cleaning. But earlier, because of the scarcity of the water, what we used to have every 10 days is a cycle in a cleaning of the of the module because of the swelling. And so inverter side, definitely string inverter, as I told you, there are at least 14 features, which are advantages for the string inverters, right? Okay, right from the, side wing, kind of a, the the kind of a, if they are in any kind of a side wing, any kind of a, breakage on the module or part drop, or maybe any other thing. So the string inverter is very easy. If you see there is any malfunctioning of the string inverter, you can change it. And always there is a several string inverters in the standby in the stores, right? Higher wattage modules, higher wattage obviously inverters, like there is a limitations as on date, like 220 watt string inverters. But in future, I think it's not only the voltage but also in the higher current is a recommended, in a sense, as I told you, for G12 wafers of the cells, and then the corresponding modules has a handling of the higher wattage with the bifacial configurations and maybe closer to 40 amperes. So therefore, it needs to have accommodate, the inverter should accommodate the all two formats, the higher wattage as well as higher current modules, right? System design point of view, yes, single axis trackers is a most recommended, because compared to the fixed tilt, it gives a in at least 4 to 5% generations more, but at the same time, there is a capex involved for a single axis tracker. Portrait design is also recommended. AC/DC ratio, depending, though I have mentioned only 18%, but yes, depending on the locations, if it is in the Rajasthan, because when we are sitting in the north, you don't get much on a north of India, don't get much on the gain on the particularly on the single axis tracker. But yes, and the Rajasthan, the Madhya Pradesh, is going to south, you get a kind of a huge, the albedo gain with the tracker. And robotic cleaning is obviously recommended, and drones would be available in the in-house, in a sense, chauffeur, for the not only for operation maintenance point of view, but also from the project point of view, we need to have a drones, and these drones can be used either the visual or maybe infrared imaging configures to find out if there is any kind of a high temperature in the module, operating temperature means, or may kind of defect may arise, or maybe hotspot, those things can be checked. Next thing is the procurement is very, very important. What we say, it is a kind of the two pillar from the engineering and the constructions. So what is recommended is the right quality, right quantity, right price, right source, and the right time. So there are different recommendations, like type of the goods and the work services required, method of procurement, potential sources, estimated cost, source of fund, requisitions, and then delivery time and the place, then evaluations criteria, review mechanism, justifications of the non-competitive procurement. On the supply side, PP modules and the inverters, MMS, transformer, HT panels, cables, DC and AC, switches, and then monitoring services. Contracting side, AC/DC installations, piling. Normally with there are different sub vendors and all. We have to do either the civil work or the road, drain, and the control system, the boundary walls and all. Well, from the procurement point of view, there is a flow chart. The issue of the technical specifications which are coming from the engineering team, and then what you do actually initiates the purchase requisition, then RFQ and call for offer and the commercial bid, and then evaluate the offer and the negotiate and the finalize the vendor and issue either purchase order or the work order. Then advance payment with the letter of credit, or maybe with the other the BG bank guarantee and all. Then productions monitoring and the quality check, finally before delivery, and then monitoring dispatch. This is very, very important. And the logistics, whether it is coming by truck or, domestically, or if it is imported, by ship, tracking how much time it will take, who will be then clearance if it is coming to the imported, and then clearance at the port, and then delivery at the site. So all the things are very, very important in terms of the project management as well as in the procurement point of view. So my recommendation of selections of the right vendor is critical to achieve the following results, because the plant life is more than 25 years. PPA side is 25 years, but yes, the selections of the supplier to the contractors after complete due diligence by the competent authority, in a sense like whether it is in-house authority who can visit the factory or any other vendors and their capability, and then if not, then appoint a third party who can accompany either from the TUV or maybe any other third party recommended vendors. The evaluations including the global rating, in a sense like if the supplier has got what kind of rating with the tier 1, tier 2 and all, the capacity of their productions, the manpower, what the kind of machinery they're using, what kind of bomb they are using, what is the kind of supply chain management, and what is the lead time, customer feedbacks, what kind of feedback they have, a good or any kind of complaints are there. The global sourcing to take the competitive advantage from the low cost countries. As on date, like the India is not manufacturing much of the solar cells, so we are importing solar cells, and which are very, very competitive now, right? 4.5 cents, less than 5 cents, a watt. So that's a very, very cost advantage from the China as well. Okay, special attentions on the high delivery time item, particularly the module transformer and the switch gears, ensuring required quality, reliability certifications, particularly the IC, BIS, ALLM, which are complying to the Indian context. Best price for the warranty without too many limitations, including third-party backed insurance. This is also very, very important for not only for the module but inverter as well. Technical support, after sales, local presence, ensuring supply of the spare parts for next 25 years. Focus on the R&D activities and the new product development. Compliances on the EHS. This is very, very important. There are certain gases, say for example, silent. So we are sourcing, say for example, a solar cells from any company, and by chance anything happens. So the safety is very, very important, that it should have an uninterrupted supply without any kind of complications. So we check the compliances from the environmental health and safety point of view. Risk mitigations, we have at least 2 suppliers in case if one is stuck because of the quality or any other factors, and other contractors as well. The financial health of the supplier, the contractor, local sourcing to optimize the logistics, and the quick response. So it's always good to we find out the equal quality of the material which is supplied locally, and the PO values with the either the ex works basis or FOB, CIF currency, and the tax and the duty, right? Next is most important part, in the project management, is that land acquisitions, which is taking more time for any developers, or though it is not part of the EPC, but land acquisition is not clear, then it takes 180 days, grid connectivity 120 days, engineering test like 30 days, site infrastructure 90 days, offices 60 days, team mobilization 10 days, boundary wall fencings like 45 days, module supply, if it is imported, 150 days, but sometimes locally also, depending on the volume of the their productions, it takes more than 3 to 5 months. BOS and the balance of the systems, which is 100 days, total constructions 180 days, including AMS supply, civil works, and the erections is 80 days, module installations 30 days, DC cabling 30 days, AC works 150 days, substations way work 150 days, transmissions line work 180 days. This is also one of the highest lead time, and the test is 10 days, and then charging of the plant, though it is 1 day, but it can be pre-tested, and then final charging is a 1 day, right? Okay. So my recommendation that when there is a plot approach, that means if there is a full project is 250 megawatt, it can be divided into 5 plots of 50 megawatt each, and then 50 megawatt also be divided like in the 10 megawatt is clusters, but depending on the kind of AC-DC ratio, if it is from the AC side is 10 megawatt and DC is something like an 18 to 20 percent overloading, so it may be 12 megawatt or 12.5 megawatt. So division of the project into the sub project of the 50 megawatt, and then each pilot is treated like an independent project, ensuring on time executions within the budget and meeting all specifications and the quality requirement. Why plot approach? Each of the project management, project skills, the ideal for the cluster approach. On-time executions need to be parallel, project executions, efficient supply chain control, accurate tracking and the expeditions. Efficient constructions allows delinking of the constructions with the other functions required on the site. Advantage: independent project managers, constructions manager responsible for the plot delivery. I'll explain in my next slides about how many people will be required and how there can be optimized in a better way. Optimizing utilizations of the resources, competing resources, and internal benchmarking results in the higher standards. So manpower, what you need, for this kind of a 50 to 100 megawatts, like 23 to 25 numbers, right? So there will be a constructions manager, and under him, the admin and accounts, HSE, civil, planning of the engineers, electrical engineers, and then the quality engineers, stores, and the others. But yes, project management, there is one more guy, then electrical engineers, there is three, then technician and the supervisor, 8, and the civil engineers, 3 numbers, right? This is a kind of in a pictorial view about during the construction site, how it works, right? I've seen the path 1, path 2, path 3, path 4, and path 5, the vertical positioning, post installations. This is a kind of in a civil area, and the MMS installations and module installations and all. Then the IC and the TFO foundations, the skid installations and all, right? So this DC cable side, CV fixings and the terminations, and the terminations of the inverters. Then finally HT cable trenching, cable laying, and then transformer and HT panel installations, the route, the watchtowers, and the monitoring systems, how. But the safety is one of the biggest concerns, as you understand that this is a kind of a solar power plant, is a high voltage and high risk. So there are different do's and don'ts over here. It's mentioning and pictorially. And then there are different kind of pre-commissioning stage. First of all, the snack test of each and every equipment, module test, and then the peer test, and the final the acceptance. This is called, the overall acceptance test in the power plant. Okay, so recommendations is that, land availability is very important so that the project team can start their work, the project management and the development boundary wall, the fencing, as I told you, this will be very fast. Deployment of the tight security, tight project management and the resource mobilizations on the site, cluster approach for the better project management and the project quality, and check the quality. Quality check is of all BOM items at the site before commissioning, because something like, or we do, in the factory or in the third party lab, but finally when it receiving at the site is also very, very important. Safety is the top priority, absolutely, with all stakeholders at the site, means with all the sub vendors and vendors, those who are working, including our all employees, we have a kind of safety shoes, as well as, on the top of it, a special type of, helmet and all. The grid connectivity is also important, ROW issue. Employment, few guys of the local area, so that, they are also motivated and involved, so that local panchayat is also happy. Development of the internal road for the smooth movement of the vehicles with the BOS item. Testing all electrical component before connection. Okay, this is a kind of a total quality control of the module. I don't discuss much. These are the kind of a packing material and unpacking, how it has to be unpacked at the site, and then the recommendations, the do's and don't, during the installations at the site. And pre and the post commissioning stage, there are different, which is called the equipment, where you can have a control with the thermal imager, whether with the drone-based system, as I told you, the IP pressures, and also a portable EL, means diagnostic tools. You can have a, immediately, even after receiving the module, you can check it before charging it. Even when they are putting on the in the table of the array. So that gives a kind of a comfortable, things are all right. So my conclusion is the technology should be the most focus area of the new and the innovative high efficiency module and the low temperature coefficient, the focus area of the value engineering, as I told you, and the reliable product and the quality control at each stage with all stakeholders, including the vendors and the sub-vendors, then tracking of the high lead time items with the alternate suppliers so that, all the project management, they have their project timeline and they can track it. The tight project management with the internal, the external, the team members. Internal means including all the engineering team, procurement team, logistic team, and the external men, those are the vendors and some vendors. The rigorous test and the pre-commissioning, as I already mentioned. So finally is that let us work together with all the above stakeholders to improve the efficiency, quality, product performance, reduced degradations, consumptions, reuse, recycle of the BOM to achieve the better LCA. Reuse, recyclement, this is the future things like when you sign an PPA, there is always a kind of the declarations like how we do the kind of when the plant life is over after 25 years, or maybe because of the premature case, in case of either the inverter module or the structures, how to decompose, particularly if it is, environmental hazard, there are different technology like, cadmium telluride, where the module how to be disposed. So we have to take care of on such and such things, but it's not only the LCOA levelized cost of the electricity, but it's also there are different biddings. Or also we are doing, it's called levelized cost of the storage. Storage means whether it is a BESS battery energy, storage systems, or the pump hydro, which are also the is a huge high volume, kind of a storage concept, and the energy payback periods, with all different materials that we use. We also try to figure out, how quickly, the kind of the energy we are giving it during the productions, how you get it back. Thank you very much and for your patience, and wish you a very good day. Bye-bye.